who knows more about it than anyone. So.
You guys can see this, okay?
Yep. Has it turned up yet, though?
Yeah, it's sat here, mate. It's sat next to me. It weighs 15 kilos.
Why haven't you installed it and got it up and running yet then?
I've been working, trying to get all this done for today. Right, anyway, just the abuse, the Welsh English abuse, it never ends. Right, everybody, we'll do the usual, same introductions as before. This is a different day, and we'll go in 5-4. Hello, everyone, and welcome to another E5 podcast. I am your host, Paul Meenan, and we're back again. And I am here with my brothers and tag team partners and a guest. Introduce yourself, chaps.
Hello, I'm JW.
It's Dave Watts here, Sparky Ninja.
I'm Paul Skirm.
And lads, we are joined again, thankfully, from the electrical supply industry by a peer, a mentor, and an incredibly nice chap from across the border. Introduce yourself, please, sir.
Hi there, my name's Gordon MacKenzie, and I worked for the DNOs since 1985 to recently retire in September 2021. You have put a shift in, sir. Thank you very much for joining us. And today we're going to talk about our favourite subject in the world, diverted neutral current, or neutral current diverted, depending on which document you read. I prefer the latter. I prefer diverted neutral current, but it is what it is. It's something that's a known issue and also an unknown issue. So we're going to debate this as a group of individuals, a group of engineers who are friends with an opinion. This doesn't mean what we're saying is gospel. We're not here to slate any DNO or any network operator. What we're trying to do here is make people aware of the risks, make people aware of the hazards, so they can better keep people safe. So that's why we're doing it. Okay. So if we get to the start of what actually is diverted neutral current, so there is a document which you can download from Tangle Tamer's website. Please just Google Tangle Tamer's electrical engineers, and you will see an interesting stuff button. And for many years, we have worked with them to develop some documents following studies, and this paper is freely available, and it's called Diverted Neutrals, and it's a discussion of experiences and finding from working on TNCS supplies. Now, for the learners listening to this or watching this on YouTube with the visual aids, so if you are listening, please watch this again on YouTube, and you can see the visual aids we're using as prompts, like we would in a webinar. TNCS is also known as PME. It uses a CNE cable, all complex stuff, combined neutral and earth. And the PME refers to the earthing of that supply cable. So that's put it as simple as...
I have to chuckle in my head, though. When we talk to learners, we go TNCS, PME, PEN, CNE, and they go, what's the difference? It's the same.
Of course, it's all the same thing. It's defining different components.
Different components of a protection system, yeah.
It is. So it's freely developed, and in that they have tried to, because the industry hasn't defined it, and I assume at some point the IET will define it in a little bit more detail for us in a book. We've come up with a DNO, or a consumer's neutral current, which flows partly or wholly in a path other than its own circuits, neutral conductors. Commonly, these flow in earth networks, earth structures, service pipes, rebar, or drainage system, together with a variety of CPCs and their associated equipment structures, CNE conductors, and also the mud of earth itself. It's like saying a mad, uncontrolled diversion of power that should be controlled. We used the water pipe analogy, didn't we, on a TNS system, live in, live out. This TNCS system, it's live in, live out, but the earth is connected at the origin. So as John has beautifully done in his videos, if you break that combined neutral earth, or a term known as a broken pen, which there is an article from the IET, which is called Broken Pen, written by Michael Peace. And it's a very good article with some great little videos and visuals that talk to you about diverted neutral and how it's exported and imported. Because it's effectively, well, we'll show you a diagram and take you through that anyway. Let's move on and just talk about what normally happens within an installation. Mr. Ward.
Yeah, normal is something that's useful to look at. So what we've got here is a three-phase supply. All the fuses are taken out, and we've got a clamp meter there on the main earth conductor, and it's one of these where the display is separate so you can actually see it. And unsurprisingly, we've got no current there whatsoever, so zero. And that's exactly what you'd expect to find. So you've got no power going through the installation, and surprisingly enough, there's no current there. So that's what normal looks like. And then we've got the same installation where the fuses are in, clamp meter around there again. And we do have, in this one, 4.3 amps of current there. And again, this is normal as well, because it's pretty much inevitable on installations. You're going to get some current on the earth conductor. Depends on your installation, but it's pretty much inevitable. So again, that's normal. Fuses in, you get some current there. Fuses out, it all disappears, goes to nothing.
Indeed. And we kind of call this protective conductor current. Some people call it installation leakage. There are different methods and means of measuring. There's a great document available online that shows where and how to put your clamp meter to measure installation leakage between your line and neutral tails, and then also your protective conductor current on your earthing. But that's normal, perfectly normal. It's a nice, healthy but old TNS. And it's just to show you this stuff. Leakage does happen normally on an installation. But let's just take everybody on a little journey through the DNOs, because what we're talking about with diverted neutral is not an installation, not an issue that electricians are taught about in college, other than this broken pen or the hazards with TNCS. So if we can show everybody what the DNOs look like. So there's an image on the screen of the electricity networks, and there is effectively 6 major distribution networks now: Scottish and Southern, SP Energy Networks, Electricity Northwest, Northern Power Grid, UK Power Networks. There used to be about 14, I think, DNOs or regional.
Seem to have been swallowed up by other ones. And
they have. They've become bigger and bigger.
Yeah.
UK Power Networks is made up of the old Eastern Electricity, London Electricity, and the old Seaboard, or Seaboard Mafia, as we lovingly called them. And that's now UK Power Networks. And they still have their structures. They're just under a bigger remit. But that's the electricity boards. And wherever you live in the UK, it's really important to get to know who they are, contacts, and maybe even your local engineers. Because having a good relationship with your engineers really helps build a trust when you find an installation that's really on its knees. If we move on, one of the things that the electricity networks produce a lot of are standards. So EDF, UK Power Networks, who used to be called EDF, produce earthing standards. Onward, Dave, keep going. Lots and lots of standards, including visual guides to what should go into installation consumer cutouts, guidance on cutouts. The ENA, they produce documents which filter down. The ENA are the Energy Networks Association. They're the voice of the DNOs, and they produce guidance, which they get some instructions from Ofgem, and then that filters into the DNOs into all their standards. So if I read a Scottish Power standard or a Southern, there'd be quite a lot of synergy within a few years of reading all of these. Gordon, is that, am I right? Is that your...
Yeah, pretty much, Paul. I think there was, a commonality with the network and how it's constructed as well. So that's true.
Is there at all a mechanism where one network could have a special circumstance deviation from what would be a generalized rule?
Yeah. Example of that would be the points within the SPA Energy Networks network, where multiple points of earthing were done. So we did that slightly different for the G12.4 standard, adding additional points in to joints.
All right. So it's very important to obviously refer to ENA, but also the local power networks.
Yeah, absolutely.
Approach to things. Okay.
So this podcast webinar hybrid type thing, we've just recently done one on phenolic, which Gordon joined us on, and there's a perfect example of the old JW cutout, as we lovingly call them, but made of a phenolic material, which we discussed the risks in that. So please go away and watch that, and also watch our earlier podcasts on earthing, or listen to them on earthing and diverted neutrals, where we start to talk and debate. We've done a lot more research, and we're very privileged to have Gordon. So on that journey of research, one of the things that I did was my local DNO are UK Power Networks. Dave. Oh, sorry, no, I've jumped the gun. Apologies. But I'll carry on talking anyway. One of the things I did was I did a lot of research at UK Power Networks. Now, this intake is very familiar to me because it's my house. And as you can see, it's an old TNS with the old 951 clamp still on it. And we asked this question in one of our DNO webinars, is what earthing system is it? Now, it's fairly evident it's some sort of butchered attempt at TNCS. It's since, by the way, been changed and upgraded to GRP, and it now looks beautiful. But what is interesting is during this research, in reading the DNO standards, the DNOs have created something which I term hybrid TNCS, where it's PILC in one point, and we've discussed this previously, and then the cables are repaired with a CNE or a pen conductor style cable where it's TNCS, and you get a hybrid. Then you don't have that separation between your earth and neutral. It becomes a hybrid system. Is it really true PME though? So when they do those joints, they should theoretically, under the DNO standards, and Gordon will correct me, lay a rod next to that joint as a low impedance earth. And as Mr. Ward has talked about previously, in theory, PME and TNCS is a very safe system because multiple earthing means that your rising potential in the ground is sufficiently low and the impedance is low enough to protect persons in the network. Am I wrong or correct, Gordon? What's
No, correct. I think
Okay,
the interesting thing, I was looking at the cable there, Paul, is that an underground service that's coming in that image?
Yes, it is.
So we're obliged as a DNO to comply with ESQCR, and the sheath of that cable must be connected to earth. So the distribution of that cable is SNE constructed TNS, but it looks like somebody's decided, for whatever reason, probably because the earth has failed at some point on that, to dip it in beside the neutral and effectively convert that.
And that's what we saw in a lot of our
Yep.
DNOs. By the way, you're bang on right, because I raised that with the regional engineer who wrote me a letter telling me that once I've dug my driveway up, they'll come and put a new service in.
But they've done nothing at the other end, have they, to kind of create the system?
No, and this is the point. If you draw a map on your local street map and you just branch loads of cables in, then they're old PILT SNEs. The PME conversion will be either jointed repairs or a link at the substation and a link in the cutout.
I mean, strictly speaking, if we drop out of the DNO area now and come into 7671, for want of a better way of putting it, we've got an earthing terminal there. An earthing terminal for the premises, connected to a TNCS supply, with an extraneous conductive part coming in, which isn't bonded. Gordon nodded, yeah.
It's literally a shocker.
Yeah, it is. Yeah, you've got two different earthing systems. Because obviously you're going to get a voltage rise drop. There's going to be a voltage on a PEN and CNE conductor.
And in my defence, I have control of the installation.
Yeah, I know that.
But yeah, you're absolutely right. So yeah, that's why I won't let my missus near the beautiful electrical installation that I've done around it.
Yeah.
But yeah, is it true PME? That isn't true PME. It's hybrid. It's a
You've got
Frankenstein.
an exposed earth connection there as well. It's not even as if it's enclosed. You know, your neutral earth connection now is exposed, and the sheath of the cable terminals exposed as well. So you get two different.
Just also to be clear, there is a GRP cutout surrounding all that now. That's what it was when I moved in. So yes, but I still have control of it. But yeah, I get what you're saying. I think the point is you do get these hybrid PMEs. So Paul, what would you put on the 7671 certificate if you knew that? Would you put that as a TNCS or would you put it as a TNS?
To be honest, I would put it as a TNCS because it's a combined. They're using the neutral and as the earth conductor in the DNO side of the cable, and they're splitting it once it comes into the premises. Yeah. So I would put that down as a TNCS personally.
No, I agree. I
mean, your full current behaviors would be based on TNCS or basically neutral loop path characteristics at that point.
I agree. So moving on, one of the other things we've done, this is just a good example of the hybrid, is I quite a while ago wrote to UK Power Networks, and what I said was, hello, I'm undertaking research. This is not necessarily my wild opinion. This is based on research, which is why we've not been doing lots of podcasts. We've been researching. And I've said, may I ask a question? Given I have read your recent suite of LV earthing and supply documents, can you confirm the bulk of supplies to homes are actually PME or PNB, if it's out in the wild, configured in the style of TNCS, as we've seen in the recent image? Regards, me. And the wonderful team in the asset management department of networks have said, hello, Paul, it is a reasonable assumption as PME has been around since the 70s and many legacy networks have been converted. Now, that doesn't necessarily mean with electrodes every 30 meters, but they've been, as we've seen, Frankensteined. So I see people on social media putting down TNS, and I look at it and I think, well, how do I know that's TNS? When odds are, if I went and looked at myself, I'd probably realize that's TNCS. And this again, 7671 is a real challenge.
It's an area we've not been told to explore or really take any kind of interest in. I know 7909 had the verbatim to say that, you know, it's unlikely that TNS are TNS anymore. They've been most often repaired. to become TNCS because there are lots of concerns with TNCS.
Well,
so when you have these concerns with TNCS, when you're using external systems outside, but you go see, oh, it's a TNS, it'll be fine. They're having to add that little comment, saying, well, maybe it won't be fine. You know?
Yeah. I mean, it's a difficult one because, you know, you then Spark has to then assume what is going on in the DNO network when he may not be able to get access to, maybe the cable access is restricted, or it's, you know, he doesn't really got the ability to check what cable's coming in, perhaps. And if he's presented with a separated supply, you know, I mean, I've seen cables coming into properties with a separate earth conductor coming out of the ground, separate green and yellow, coming out of the ground with the DNO cable.
Yeah, but that could be an S&E service. And this is the thing, as Gordon will probably agree with me, it could either be an S&E service from a repair on the street, which I've had, or it could be an end-of-line electrode for a branch.
Yeah.
Absolutely, Paul. Depending on the number of properties that are fed from that connection point there, greater than 4, we would have taken a support earth in, and that you know, you would see that the earth going out to the earth electrode outside, or we only ever did it with single premises where that would actually be the P&B connection.
So I'm going to be controversial here because I can see and read Paul's face. Is it fair to the electricians to have to know what's going on the network? But then again, is it fair for the electricians not to know that if they're in a TNS looking installation, that a 6 mil bond isn't sufficient and it should be 10 mil? Stuff like that. Or should the electricians be given guidance to make an inquiry at each installation to check with the DNO and have them verify it? Because I've just done that in email for UK Power Networks, which is all of the southeast of England. And one of their very senior people in asset management, and I do mean senior, has come back with, yes, it's been converted. So if I now have that knowledge, why am I putting TNS on a sheet if it looks like TNS?
I don't know what the answer is. But then, if once you get up to larger installations and larger supplies, you may have a dedicated DNO transformer.
Yes, and that absolutely will be.
That's pretty much, I think, where we should have only exclusive use for the consideration of TNS at that point.
Yes.
Well, but then you have PNB, as we call it.
As an alternative, yeah.
As an alternative,
the consumer's end, yeah.
Yeah. So
there's definitely, to my mind, a lack of transparency with what the DNOs are doing in modifying their networks. And as far as the Sparks in training and Sparks in general get to know about what's going on, but then can we expect the DNOs to give that level of detail at all times
but we could expect a bit of collaboration here, because in their own standards, they require communication, cooperation with the homeowners. And that isn't also happening as well, as we've talked about in other podcasts. But if we kind of move on and show people, and this is for the learners now, but it's an interesting thing. Keep it in the back of your mind. Do your own research. Ask your own. Send your own email. This was my attempt to garner information. And I have, by the way, since emailed them back about this, which we'll cover in a future podcast. Okay, so moving on to the bit now where we explain what this is and how it looks like for the learners. So if we go to the next visual. So this is my favorite image of all time. This was taken, this is me, I'm a visual learner. So I had on one of my railway stations a TNS supplier, a PILC supply fail in a car park. They dug it up, they repaired it, where they jointed the new C&E cable onto the old PILC. And I was very fortunate to get a lovely little section, cross section of both of the cables, and I just put them next to each other. And the minute I did, I just went, light bulb moment. That's the risk. That's the problem. As you can see, if we just move on a slide, we'll introduce them a little bit more detailed.
I still have a bit on my desk.
You do, didn't you? Yeah. There you go. So what we have here, John, you're better at this. Go on, you explain it to us.
Yeah, we've got two examples of cables here basically just been cut through so you can see what's inside. This is the sort of stuff that would supply a property. If these are 3-phase cables, but they're also used for single. You just tap off one of the phases and the other. So on the right there, we've got the older type, which has got copper conductors, and you've got 4 conductors inside. You've got your three phases, L1, L2, and L3, and the neutral. So they're all separate, insulated individually. Around the outside of that, we've got the outer, which is going to be earth, usually lead or something in the case of that one. So that's your SNE cable, so it's separate neutral and earth. One on the left is the newer type. Only 3 conductors inside, and they happen to be aluminium conductors as well. So L1, L2, and L3 are inside. There is no neutral, but what's around the outside of it are individual copper wires, and those are used as the neutral and the earth. So it's all combined in the same conductor, and that's CNE, or combined neutral and earth cable. Mainly used because, of course, it's much cheaper to make because it's only got 3 conductors in instead of 4. So that's pretty much what you're going to get on any kind of new installation.
Yep, that's the standard now. And that one on the left is known as combined neutral earth for the obvious reasons, also known as the PEN conductor. So the difference in terminology is the descriptor, really.
Is this cable cheaper? Is it easier to terminate? Is it what's the reason?
A video from the 1970s published by Path. Yeah, it's on YouTube, and it talks to a REC, or a regional electricity company, about the introduction of this new cable called CNE.
Oh, I thought you shared on Instagram, didn't you?
I did share it on Instagram, yes. Yeah. And the main reason it gave was purely it was a cost-saving cable, which gave greater value to the networks, which was fantastic. As we know, we talk about whole life approach, life cycle of the cable, what happens if it fails, because obviously that little bit of copper around on the left there, if that breaks completely, you then have what is known as a broken pen, which in your installation, if you switch on, you potentially can have 240 volts in your metalwork, or you will really. But if it's not broken, then I think my mindset, and the easiest way for me to talk about diverted neutrals is diverted neutral is effectively a precursor to a broken pen. That's the way I look at it. You have current flowing, not necessarily all the way through that combined neutral and earth, because there may be damage. The joints, some of them cores may have snapped, be corroding, may be high impedance. So it's not necessarily the path of least resistance. And maybe it might want to go through other locations. Now, this has been known about for quite a few years within the networks. It's something they descript very clearly in their standards, as we see. But if we move on, there's even some safety notices of some incidents. What we have. Gordon, do you want to talk us through this neutral current diversion?
Yeah, fairly briefly on this one. The network itself was an interconnection, an NLV main interconnected between 2 substations with a couple of wee branches, fed about 72 properties off that. But it was one of these aluminium neutral earth conductors that ran through the main, and it had failed in multiple positions. I think by the times the guys had got to joint number 7, they gave up on the fact that there was no neutral in the main at all. But there was no flickering light calls. There was nothing, no indication for any of the customers that there were any issues until the customer's jacket fell off the hook in that property, landed on the gas meter, and proceeded to go on fire. And fortunately, the customer was in, smelt the burning, and managed to get there pretty quick. And that network was operating 72 properties, we don't know for how long, without any network neutral whatsoever. And the current for the properties was using a cast iron gas main and the services for the property to breach through another section of houses onto a healthy neutral and return to the substation, back to the same substation on a separate LV. So we only became aware of it because of the level of temperature of the customer that setting that jacket on fire.
It's a really interesting phenomenon I've been dealing with myself, but I like the recommendations and action points as well. On the ones that I've found, I've just recommended using clamp meters before you start working on any earthed equipment, just to measure and gauge what's going on, what's the behavior of the installation. As we saw earlier on, a normal installation, when the installation's isolated, it shouldn't be a problem. If you isolate an installation and you find current flowing, then you might want to see, why is that appearing in my installation? There's nothing coming from my fixed installation, it's coming from somewhere else, henceforth the term diverted neutral current.
Yeah, I mean, and fundamentally the test isn't hard. It's not live testing to the point of actually creating exposures. It is a simple test to do.
The information that came from the field staff initially for that incident was there was voltage. They were reporting voltage on the gas pipes. So there was no precedent for applying a clip-on ammeter at that particular time. And it's only when, you know, we got the information about the jacket and that we says, well, you know, it's no voltage, it's set fire to the jacket. It's obviously current. It's, you know, go and clip that clip-on ammeter onto the pipes, tell us what you find. And I think in the property they were in, it was like 35 amps, something like that, flowing through that. So we knew at that point we had that.
And was that the demand of the neighbouring property? Was that the demand of the neighbouring property? Was it?
It turned out it was quite significantly more than that. It was quite a few properties. And the reason we found that out was almost by chance. We had isolated a section of the network. We had removed all the cut fuses in the property. We had cut the phases L1, L2, L3, and the boys were about to cut the neutral when the hairs in the back of their neck stood up, and they thought, can we do this safely? At that point, we put the clip-on ammeter around about the neutral, even though the section of cable, a radial section of the cable, was completely isolated. It turned out half the housing scheme was using that as the route. So had the boys cut that, we would have lost the only neutral back, and we would have had the, you know, the expectation of an open circuit neutral at that point with all the damage. But as I said, that was all new to us at that point. There was no precedent for testing in that manner, and we had to go and support the guys in site to try and work out that, because it was a very, very complicated situation we were in, knowing that we had 72 customers connected on supply via a gas pipe, effectively.
Yeah, and you didn't have a rule book or anything to kind of...
Absolutely. Yeah, correct.
And it's an incredible story. Luckily, it got found as well, and before, you know, it got much worse, which is a positive. But yeah, so using a clamp-on ammeter, and again, the IET article, the Broken Pen article, is excellent. It's got some really good videos. So I'm going to recommend it highly, because there's a lot of work gone into that by the IET, and the recommendation at the end is bang on, which is use a clip-on ammeter every time. I think it should just be an essential tool in most electricity tools.
I'm hoping recommendations will come in with Guidance Notes 3 at some point.
Fingers crossed, hopefully it will do as well. But if we move on, it leads to a bigger question, Dave, because, let's just keep moving. These are just some of the images from the report blown up.
The peaks, you want to go to the peak?
Yeah, let's go to the peak. So I've begged this question for a long time, is if the diverted neutral current, because if you think about a network, and we'll show an image in a minute, if you put a clamp meter on, you get 3 amps or 4 amps. Don't think that's the total neutral current, because energy or electricity will take multiple paths of least resistance. Your installation may be 4 amps of 150 that could be diverting around multiple electrodes or parallel paths. And it led me to ask a question when I started to find this. Could we define the installations as live or not live, or charged or not charged, or energized? And in our past podcast, which please everybody listen, because I'm not going to repeat it all here, we discussed the definitions in the IET wiring regs and various other standards. And if you have a significant level of energy, you could identify it as live or energized. And so it leads to the safe isolation question and safe working practices. But I think if you just move on, this question is a lot bigger, because I think as an industry, we've got a slight iceberg of ignorance, and we'll show why. And this isn't a detriment or defamation of anything or anyone. This is more about that communication across the industry, that partnerships, as to we know about it. It's in certain documents, but maybe the practicing electrician who's out there in the trenches by himself maybe needs a little bit more ammunition to keep himself safe as things are going on.
Let's not forget, in the domestic realm, which is where an awful lot of these things could be happening, is where a lot of electricians work for themselves.
Yeah,
you know.
Mr. Skirm, what's your thoughts?
Yeah, and on top of that, I think that there's still a lot of investigation being done with regard to this, and how, you know, we know that broken pens cause it. We know that there's a lot of old cables out there. We know that it's not broken pens, but a high impedance pen can cause it. You know, there's going to be a lot of other things out there now. You know, if we think about tripling harmonics, even perhaps where you've got a greater neutral current than you have phase currents, You know, these things are all going to be looking for their source back to the transformer, back to the neutral point, back to the star point, back to Earth. So I think there's just somebody needs to write a book.
It's a good point. I'm looking at somebody who might be in this slide deck.
Speaking with a little bit of understanding on this, Paul, do you see any of the movement in the future for domestics to introduce more tripling harmonics with regards to the equipment? Or so do you think that in the near future, we're going to start putting a lot more stresses on the neutrals in the ground?
So I think so.
Okay.
Around me now, all right, I'm in single phase installation. In my room, that's turned on. I don't think I have one linear load. Everything is electronic.
Yep.
I got 2 printers alongside me. I've got a disk box, I've got my computer, my monitor up there. These are LED lights. That's an LED lamp. That's an LED lamp. Another computer behind me, electronics. My network gear up there, electronic. You know, nothing is a linear load anymore.
And just for everybody listening here, years ago, traditionally, I think was linear. Now most loads are non-linear, which cause more harmonics and in the pursuit of energy efficiency. And weirdly enough, I had a power cut in my area the other week. Having spoken to the DNO, because I'm ex-EDF myself, they were even telling me that they're refusing to give now for EV installations 100 amp fuses on the 63. Why? Purely because they're protecting their network. It's not about, you know, it's they've assessed, and there's only so much load profile they can give to everybody. So this rollout of EV is going to cause another challenge for networks, but I'm sure they'll overcome it and proceed with upgrades. But if we go on, Dave, let's go to a simple diagram, a nice visual diagram that we've spent no expense showing. But I do think, it's worth saying before we go on, the guys at the IET are researching this immensely as well to ensure they get the right information, the right guidance, and the right facts. We're doing this as independents because we think it's really important to debate publicly and for our peers and electricians to try and take measures to protect themselves. There's no right answers here. This is just based on research and evidence and what we've got. So what we got on the visual on the screen for everyone listening, please look at YouTube, is a very simple transformer with a conjure disc as our earth electrode reference and a simple brown line that indicates our line or phase conductor and the combined neutral earth, and it's glowing with return energies just for the visual. And you have your simple single phase cutout for a building. It could be 3-phase, could be a house, whatever. Now, obviously, where you've got the earth terminal, you bond your water and your gas as and where applicable. But if you have a broken pen, which Dave is going to magically make it happen, very simply what happens is you have that joint over time will slowly go high impedance, high impedance, high impedance. When you have broken pen within installation 3, you could have 240 volts in all your metalwork. As that pen is breaking or breaking down, you will get diverted neutral, and that may take the path of least resistance, which in this house could be gas and the water main. It will then bypass, and it won't be 4 amps out of house 3 and 4 amps into house 2. You may get 2 amps because it goes in the path of least resistance. And that is the whole phenomenon of diverted. You can export it, you can import it. It depends on where you are on the network. Gordon, is that a correct understanding? Is there anything you want to chip in on that?
No, it's accurate, Paul. It's absolutely accurate, and I think that's the key part that to explain there is the separation of the conductors and the domestic property, the live neutral earth, and then they're combined at the point of connection there to the network. And I think one of the interesting parts about that is that your RCD simply doesn't see neutral current diversion. You know, it will pass through the RCD, comes into the point of connection, and then find its way onto the pipe. So it doesn't behave like a fault. This is just a simple return path.
Absolutely. And we look down, our protected devices of our installations look downstream, not upstream. Yep. So there is obviously the technology which is supposed to, I think it's broken pen technology, or OPEN technology they call it, that is supposed to protect, which was developed for electric vehicles because of the high risk of them being outside. But if we move on, I'm going to skim through some of the references because we've already spoke about it. But the Energy Networks Association published some great standards, great guidance. But what I found really confusing is in Engineering Recommendation G12, it had 3 references to diverted neutral current and several references to neutral current diversion. So henceforth, at the top, we said it was 2 different names because we're using 2 different names for, I don't know why. moving on and just skimming through these, Dave, if you look at the section on lightning protection, it talks about, consumers' electrodes carrying most of the diverted neutral current, which is really interesting because a couple of years ago, Dave, and everybody, we were referencing foundation earthing or electrodes installations. Now, one of the considerations and worries I have, if we start banging electrodes in everywhere, are we going to mask the issue of diversion?
Well, we're going to introduce more parallels, aren't we?
And which masks the problem. And this is what concerns me. It can mask the problem. Just like a lead water main would, it will mask the problem. So it may actually hide the danger.
And it still won't make RCDs work.
We need to be thinking about safe systems of work when working on or near earthing systems, as much as it sounds, especially when they're connected as part of a... Now, we do this on the railways by default. You disconnect a railway earth bond, you can blow yourself up because it has obviously high voltage traction return in it. But on LV, obviously, you're not going to find that, but we need to maybe start considering it. If we move on again, even communication stations, it talks about possible neutral current diversion. If we keep moving, and it says it advises people to create TT installations. Interesting. So create a TT, get rid of that. How do you do that when you've got a PME supply, a TNCS supply in the street, and what distances do you have?
Oh yeah, we're gonna have to start talking about gapping at some point, aren't we?
Yeah, I mean, for me, it's simple. Where my house is, if I TT'd it, I just put the TT in the back of the garden, which is away from the cable, because I know where the cable comes in. And anyone who's an electrician, within a few hours of looking at installation, they'll kind of suss out the cable routes, to be honest with you. Again, communications, tower masts, neutral current diversions. It talks about multiple sites. Moving on. Again, G87, 3 references to diverted neutral current and 8 references to neutral current diversion. And that's PME supplies to multiple occupancy buildings. It talks about, in general earthing, neutral currents flowing within structural steelwork, for DNOs, BNOs, and how we manage these high-rise buildings.
A point worth making, Paul, the difference between G12.4 and G87 with multi-occupancy guidance is actually a recommended practice in G87, but there's not in 12.4, although the risk is the same of neutral current diversion.
So
one recognises it and has a recommended practice, but the other one doesn't.
So that's a really valid point. But if you look at the bottom, it says, where multiple PME are provided to building with structural steelwork, the main protective bonding conductors may carry neutral current, particularly if the neutral on the external mains is broken. And this is a 7-year-old document, resulting in overheating with consequential fire risk. Now, I did have an image, and I can't find it, with a bond that's got 192 amps in it, which is burnt out completely. There is also a risk of arcing between adjacent metalwork and a risk of shock or burns to the person. So this does present a hazard. The extent of limitation needs further work, but it really does need to be considered, which is why we genuinely are begging people, get contact voltage detectors, get your clamp meters, have a set of insulated gauntlets, protect yourself, go home to your families.
And at the same time, as it says here, plumbers repairing damaged pipework, other trades are vulnerable to this as well. So share the information. Yes,
absolutely. Plumbers, especially if you've got a broken pen or a high impedance pen, and you've got a water main, potentially that could mask this. And it only will you then find out when you take the boiler off and you potentially get 240 volts.
Mm-hmm. Paul, just another wee point on that as well, going back to the original incident that we had in 2014. The contact voltage indicators don't see neutral current diversion. When that's taking place and there's a conductive path there, you will only detect that using a clip-on ammeter. You do not see it. And I think the guidance video that the IET are now working on will show that quite clearly to the guys to make them understand that, that you can absolutely use that in extraneous metalwork contact voltage indicator and it will not see neutral.
I mean, you'd only get a voltage once you've created separation, wouldn't you?
Correct.
Once you get separation, well, you get your voltage.
I was actually referring to the overall risks that we discussed as well in the phenolic podcast. So having your toolbox of protection, or as Dave will do in his updated, the hidden tests webinar, which I'm throwing him under the bus for. Anyway, moving on.
Let's move on.
But this is a real thing. They're warning plumbers about damaged pipework. Within a building, this is an interesting one from Mr. Skirm. A magnetic field problems caused by diverted neutral current can be eliminated. closer still work, and reducing the vicinity of the building network if the latter utilizes separate neutral and earth. Really interesting. So we're in the field of EMC, which...
Well, there are those drawings in 444 with the TNS, the TNCS, all about not connecting neutral to earth upstream of the intake, all about circulating currents.
Yes, you mean that section that most electricians...
The tutors go, move on.
Move on.
Yeah. Circulating currents. This phenomenon will create circulating currents in the building structure.
It will, indeed. I'm more interested in the magnetic field issues, whether there's a compatibility issue there or an overwhelming of transmitter equipment, because I know that's what Paul's thinking.
Well, yeah, I mean, it's AC, so it's going to be an alternating field. So you could get you're going to get a great big 50 hertz antenna in you. Or if you've got triple inch circulating, you've got 150 hertz antenna.
Mm-hmm. So moving on.
And higher with some of the harmonics.
And higher with other the more there are.
Again, just a little image there of a clamp meter, 134.5 amps. It's quite a lot, really. Measured on an earth bond, really shouldn't be there. So when do we get into the magnitude of where this goes? And this is a question everyone's going to ask in the comments. So there is no answer to this, but Dave, I'm going to ask you as our resident arc flash enthusiast.
Yeah.
When do we go from current volume of creating some small sparks and arcs to when we do that disconnection, there's significant energy to cause a arc flash?
Well, I mean, it's relative to the environment at the same point. I mean, even if you have a very, very small amount of current and energy, there's still a risk of ignition at the point of creating a separation gap. So you're still working charged and energized. So even when you're very, very low down there, you're working with anything that can create a spark. As for arcs and sustained arcs and gapping and things like that, the standard guidance would go anywhere where the device upstream is 100 amp is where we go new. We'd then have to go, right, we need to assess risk for things like 1.2 calories of incident energy potential. Yeah. So if the upstream device is 100 amp is normally where the typical guidance will then go, no, change your working approach.
So I had a chap working with me where he was connecting a 16 mil bond onto an earth bar. And as he attached that, he got a visual big bang, like a big flash.
The big flash is, yeah. So with the big flash, that's obviously going to give you that pressure wave and that blast. The main concern is what is the selectivity requirement and the coordination upstream with regards to time and stuff. If it's quick and instantaneous, it's just one thrust.
This was a bond. This was an earth bomb, which we didn't expect to be charged.
If you have any delaying in your disconnection, that's where you're going to have significant burns and significant damage. But so it could actually be a small flash. It's time.
David, hang on.
Creates the problem.
I'm going to stop you because I'm stupid. You're talking about protection. This is an earthing system. What protection do we have on an earthing system?
Knowledge, just awareness and test for the presence of current.
And that's what I'm trying to ascertain is where's that limit? Because if it's 2 amps, is that okay? Can we?
Well, I've said this.
Sparks.
The way I'd create a system work with this right now is I would have a clamp-on meter constantly on that route, and if I was to disconnect an earthing conductor and the bonding, I would then, when I disconnect to a board, I'd reconnect them. I'd put in bypass. I'd have some 25 mil jump leads to bridge anything I break. I would measure first, then I would bridge, like gas guys are supposed to do across a gas meter when they replace a gas meter. I would put a clamp meter on, see there's nothing there, bridge, disconnect, and maintain work. Because at any time, Doris or someone up the road can come in and turn the oven on whilst I'm working. So it could be measured that there's nothing there. And then 20 minutes into my board change, loads of amps can start appear. And I would not know that. So I need to have a constant control. We can't think of it as being dead.
So moving on.
Okay.
There's the reason. So these are 2 images from 2 separate installations. So the one on the left, these have been kindly donated by a peer who we love and respect. Mr. Skirb knows who it is. But it's an installation where they were doing a brand new commercial fit out. And as you can see, there was this wasn't, by the way, energized yet. They'd connected all the bonding in, and what they found was they had current going through the pipes to the point where it actually got the pipe so hot, the lagging at the weakest point, which is where the joins over the clips, it had melted and fallen off. And on the one on the right was an installation where the current was so high through the gas network, it had melted the meter, which is mind-blowing. Absolutely mind-blowing. Moving on, though.
It's crazy.
Well, this is why I think the point of this is to talk about the subject and just recommend safety measures for people. And these clamp meters is key to this. If you take away anything, it's clamp meters. But moving on, Dave. This is just a random thing to stimulate debate. So I like to go around. Everybody knows I do with clamp meters. And occasionally you pick up some weird stuff. Now, there are documents for the railways. If you live within 60 meters, you can get transients. This is just some clamp meters that I've put on. I've got 600 milliamps of AC, but 1.2 of DC on the same cable. So what is floating around these networks? 1.2 amps DC is enough to blind any DC anywhere. So and RCD anywhere. So again, moving on, but it's just start experimenting. These clamp meters can really start educating you about the performance and the behaviors of a connected system. And Mega have got a great video online where they talk about fault finding using a Mega, which is not a Mega clamp meter, which is really good informative information on how to break the circuit down and look at the normal performance of stuff. This is one of the more scarier images of my collection, where we have a very simple installation that is completely de-energized, but we've still got 21.8 amps of energy flowing through it. So yeah, quite a significant amount. Sort of thing where, as you said, Dave, you want a safe system of work.
Well, at that point, I'm calling the wife says I'm coming home early. I mean,
yeah,
I'm not working on that, am I?
No. Paul, your thoughts?
Yeah, I mean, thing is, we're not going to know. I mean, protection-wise, obviously, upstream fusing, like Dave said, 100 amps, whatever. But it's good. Then you've got this relying on the upstream fusing to disconnect when you haven't actually got a fault.
No, it's no fault.
We've not got a fault condition, which is never going to happen. You know, we've got 21.8 amps there. So if we looked at the dual heating, as it were, you know, I squared T, you know, there's a lot of heating could go on with that, you know. And you will never know the voltage behind it until you undo that M8 nut or whatever it is and pop that wire off.
You've actually got to disconnect it and then test across it.
Indeed.
And then and before you can actually get to this, get to doing the test, obviously you've got to disconnect it, and that's the hazard point, isn't it? You know.
So
disconnection.
I'm going to throw this to John Ward now. So John, we have spoken about prosumers and the wonderful world of prosumerism. Now, coming now, presently, soon, we're talking about the new Chapter 8, prosumerism, and all the relevant bits we covered in our amendment to DPC. But in some of the code of practices now, there are requirements for switching of earthing.
Yeah, there are. And it's
it's
all fitted into how, if you're going to have, say, your power coming in, that might be one earthing system. But then if you've got what's called island mode, where you might run your house from a set of batteries in the garage or whatever, that might have its own separate earthing system. That might be a TT installation. And in order to achieve that, you can't obviously be connected to the incoming, say, TNTS service. So there is provision in there to actually switch the protective conductor or the main earthing conductor coming in. Now, fine if there's no current on it, but as we see in this image here, 21 amps there. If you've got something switching that in there, well, something could go very, very wrong in a very nasty way. So you've got a little tiny relay or something that switches that over, and there's obviously going to be some kind of arcing going on. So the first time it does it, it could just as easily be completely destroyed. So has this been thought of in any kind of detail? Well, maybe.
Probably not. Maybe not.
Exactly.
Maybe not. But again, it's that the designer of the installation, when you're considering this switching, ensuring your contacts are rated for this sort of loading. Potentially, there are mitigations you can take. But moving on, we're gonna just because people think we're talking wild fantasy, but since 2018, at least 5 years ago, there are appendices that cover neutral current diversion in the standards. It'd be great to get one term and harmonized, but within UK Power Networks, and I'm sure other industry DNOs, there's lots of good work being done on diverted neutral, and hopefully that can then work its way into the wiring rigs. I think that's one of the things that needs to happen in the guidance notes. Hopefully in Amendment 2, there's more information on broken pens. But moving on, let's just show the people who are watching on YouTube that there are references to broken neutrals. There are diagrams moving on that talks about, you know, eliminating risks from services of single point. There are general LV requirements that, you know, require, interestingly, it says safety quality continuity regs on the last bullet point. An end of main earth electrode is provided. So as I was saying, that, you know, the potential for earth electrodes? Are the requirements of ESQCR slowly working their way into 7671 potentially to mitigate the networks? Who knows? But move on. Let's keep this train running. This was an interesting one. Only one service in earth terminal should be provided to a customer or building. Multiple services to a building or customer are not recommended, as multiple services can cause neutral current diversion. Now, I can tell you now, at London Underground's Oxford Circus Station, there are 6 DNO services. And they're all linked, all of them on double drop link earth bars. And I've never, I'll put my hand up, I've never put a clamp meter around them to see what was flowing. Be very interesting to go back and have a look at that now. But move on. Unbalanced loads in the network. That was something I've never thought about. Multiple combined neutral and earth provided to the same buildings. If you unbalance the load, can that then shift network neutral currents in places it shouldn't be? Moving on. Railway installations. I'm not going to cover it in here, but there's lots of requirements for railway providing PMEs, including housing of the position, dangerous touch voltages to be met. So that's an issue that I have to deal with quite a lot. Moving on. Some interesting little weird things. I've banned Copex on my railway. This is a lovely little diverted neutral incident we found locally. And it melted. There was significant current flowing through the Copex to melt it. Quite a unique situation. I'm not going to go into the ins and outs of it, but that's just a nice visual to show that. It's
a good example of the fact that current sometimes be present when you don't expect it to be there. And
that thermal image was taken after it had stopped smoking, and we obviously isolated it. So yeah, moving on. Again, back to this image. I think we've used this in previous webinars where you've got 19.5 amps flowing through an earthing conductor. And then if we put a thermal image on it, Mr. Watts, you are our expert.
Yeah, well, as you can see, you've got the connection here of SP2. I mean, the point of this earthing conductor is smaller than the majority of other earthing conductors, and it in that case shows more clearly that there is energy on this earthing. A lot of the earthing is quite well sized, especially on things like rail, and so you'll have some current on them, but it doesn't always mean you'll see them on thermal. But you have the benefit of having the clamp meter with it. But in this case, there's no clamp meter necessary. It was evident that there was energy on that earth, and we could actually see there was a increase a bit of joule heating toward the connection with the actual DNO cutout there.
Right, so next slide. This is again just some images where checks are being made on the gas networks and the utility networks looking for the presence of this. It's interesting to see why the utility companies would want to insulate their gas mains and their water mains. And let's be perfectly frank, when they were conductive, some houses, again, Gordon or John, tell me if I'm wrong here, but years ago, houses used to use the water and gas mains as their electrical earth.
Yep, pre 1966, I think was the cut-off date for that. I think looking at the two images, the centre one, that's the cast iron gas main, so that's not a LV distribution main, that's a cast iron gas main. And there was a bit of a standoff with the guys, the gas guys, very fortunate to get the opportunity to do that simply because they were working on the main. And the reason they reported it was the main was that hot. It was steam coming off when there was water in the hole.
It was the ground steaming a bit.
And the gas guys were a wee bit nervous about that one. The other one, because that was a 1970s building, original electric heating, and they put gas in later on. But because it needs mechanical protection, they've used a cast iron gas main riser, and they are PME supplied they flats, and that's a fairly common practice in Scotland, and that's what the boys are doing. They're actually clamping that to measure the current on the external of that.
Is this a common working practice now for the gas guys?
That's very common, and where it requires mechanical protection, so where they put that externally, or where they rise up internally in buildings as well, it remains, although hopefully sometimes it'll be PE when it goes back towards the main, but as it remains connected to the building, it's cast throughout the building, so it allows current to flow between the flats.
Okay.
Yeah, a lot of that is actually for theft prevention, because if you've got big lots of copper pipes at the outside of your building, they're a bit of an obvious target for certain types of people that want to cut them off and run down the scrapyard with them. So if you put steel or whatever there, that mitigates that problem. So
maybe putting some current through them is a good little
That's a really good point, John. Actually, sometimes your broken pen isn't broken; it's stolen pen.
Stolen pen.
Stolen pen. That should be a definition somewhere. Stolen pen. Okay, moving on. So these are some interesting images from my library, which kind of just hit home the point of you can get significant levels of energy throwing through small green and yellow bonds that are attached to various buildings and installations. You can see from the images 58 amps in one, 38 in another. Again, it takes the least path of resistance. It doesn't go in a linear direction. It goes in multiple directions. But they're images from my library. I think they speak 1,000 words, to be honest with you. It's something we really want you guys to be thinking about and considering in the future if we move on. And this is one of the bugbears and the concerns I have where we have these, I know hybrid is the term I use and other people are using, but Frankenstein, whatever you want to call them, multiple configurations, where an SNE cable is to be completely or partially replaced or even repaired. And the premise is supplied as a TNS sheath, earth terminal provided by, and this is the UK Power Networks document I'm referring to, the customer should be given the opportunity to have a PME terminal made where practicable. Now, I had a supply change recently where it was done with a SNE to a CNE. There was no opportunities done. There was no checks done. And if this option is chosen, it'd be necessary for the customer to arrange for their installation to be checked to ensure it's suitable for connection to PME. So I'll refer to bonding sizes. But when does this ever happen? And I think we've mentioned this before. When does this happen? Have we got, as my email said, that you can consider most things TNCS? That's fine, but how many people have upgraded their bonding and considered bringing it into line with those TNCS requirements, which is why I think using a clamp meter is an essential thing. If the customer does not wish to adopt PME, the existing SNE may be retained. And this is where sometimes you get an old PELC cable and there'll be a new green and yellow. And that can sometimes be from the joint, and Gordon, you'll probably correct me here, but they will sometimes run a separate earth from the joint to maintain that SNE configuration.
Different DNOs have different policies regarding that, but yeah, you're absolutely right. It's
it's a really valid point, Gordon, because as we said earlier on, different DNOs. So if you're listening to this around the UK, get to read your own DNO standards. This is just us based on our experience because we're all in the South, and it's really valid to go and do the research. Paul?
We're not all in the South, are we? You know what I mean?
I live in Teesside.
I'm in Wales.
Oh yeah. All right. Can I rephrase that as in accordance to Gordon, we're all Southerners.
Oh, okay. Right.
And yeah, so yeah, they're actually right. Sorry, I feel like you're so close because we talk all the time. I feel like you're all down the road because we're so connected virtually. But yes, moving on.
Moving on.
So a couple of last bits before we wind this up. So this is a report that was produced by Nottingham University and one of the EV manufacturers. And it's got some interesting broken pen statistics, which we have done an FOI to get some updated stats on, where they have broken pens resulted that were reported to the HSE, and they've categorized them by injury and non-injury. And in 2018, 41 people injured by broken pens, 348 non-injury. You can see there's kind of a trend of numbers going up.
There's a fairly good, healthy upward trend with some of that.
Well, if you look at the numbers for July 2019, you can see they're well on their way to almost doubling. So hopefully we'll do another podcast when we can get the FOIs and the updated stats, but the information is out there. So it's really important when you're choosing the EV market. I've just recently qualified as an EV installer.
It would be interesting to see the 2019, 2020, 21 data, because there might be a lot of DIY work going on during that period.
No, we are getting it. We're getting it, Dave. But more importantly as well, choosing your EV. Myself, and I'm good, Mr. Skirm's going to agree with me here, the use of the open detection technology, whilst it's great feature and built in and manufacturers a great feature, I personally am not the biggest fans because I don't see evidence to prove it works. I don't like the thought of somebody being part of a circuit to make it work. What's your thoughts on it, Mr. Skirm?
Yeah, the same. I don't like the idea.
Oh, he's gone.
His microphone's cut out, Paul.
His microphone's cut out. Totally cut out.
Was it?
Okay. So with this interruption, Gordon, what's your views on? Do you have any views? Do you know much about open detection technology? Is it a thing you've experienced?
Only through the inquiry stage where we were asked, specifically, would we adopt, or would we allow it? Would we provide a pen connection to chargers? And at that point, industry policy wouldn't allow that. So other than a very basic understanding, but for me, Paul, it's always about, these things are designed with a certain type of system in mind. And our knowledge of the system was that it's not quite what you think it is. So what trials have you done where the network has been combined, or where it has been mixed and matched, or where neutral current diversion is present? Has any of these fault situations been considered?
That's a good point.
During the testing.
So I'm back. My Zoom had decided to change my microphone to a microphone that's not actually installed on my computer.
Excellent.
Software, which brings me back to open detection devices. Now, my bugbear here, I'll keep it as brief as I can. We're looking at an electrical, electronic, programmable device, safety device. I've not yet seen any evidence that any of these devices, I'm using the term open, but they're all, the open circuit pen conductor detection devices.
Indeed.
Not because there are quite a few companies manufacturing these now. I've yet to see any that claim compliance with the relevant international standard for programmable electrical and electronic safety devices.
Is that a SIL grading you're talking about?
Well, a SIL rating is a safety integrity level. So I'm not defining a SIL level for them. I'm just saying that I have not seen any that claim that they actually meet any of the recognized international standards for programmable electrical and electronic safety devices.
And that's a good point. I mean, I do it even simpler. I say, where's the BS or BSEN standard for the product? If I don't have a BS or BSEN standard for the product, how can I, quoting Paul Skirm, ensure that it meets the essential health and safety requirements of the directives, whether it be LV, EMC, et cetera, et cetera. So you can see I've learned from the wizard himself. But yeah, so moving on, just be wary. Now, on my EV training, the one thing I did like was this 6 milliamp plus device, which basically in some EV chargers, if they get more than 6 milliamps of DC leakage, which is kind of like above a type A, it just switches off, which I quite like that feature. So I'm looking for a device that does that. But sadly, when you do some research on broken pens, you come across these horrible stories that talk about engineers carrying out checks after dogs were electrocuted walking along the pavements. So these things, when they go, they can be quite nasty. So I don't really want to talk about this much longer. So move on.
Doggy.
Yeah, dog. But interestingly, this we found. John, do you want to tell us about this?
Yeah, this, those if you're not seeing this is a thing from Electrical Safety First, the round table meeting. And it was about neutral and broken pen conductors, surprisingly enough. So there was, and say this was quite some time ago as well. This wasn't like last week. This was years ago.
Yeah.
And there was this, obviously a meeting there discussing this particular issue. And I'll just read a few bits of this here.
Read it, yeah.
Electrical Safety First recent electrical installation safety roundtable focused on open circuit pen conductors, which serve as a protective earthing and neutral conductor. And when the pen conductor fails, not only does it present a shock hazard, but the diverted neutral current can also create significant heat buildup, as it typically makes the circuit via exposed metalwork, which can then lead to fire. And data obtained from the Health and Safety Executive shows at least one incident of an open circuit pen conductor is reported every day, with around 10% of them leading to injury. But as many incidents go unreported, it's believed the real figure could be significantly higher. Now, this was years ago, and what's been done about it since? And the answer is not a lot. It was discussed and identified as being a big issue, and then it was just presumably just put away in a cupboard, and no one really did much about it after that. So,
John, my concern is the anecdotal evidence suggests that open circuit pen might be a growing problem due to a range of factors: aging distribution, metallic service pipes, and the theft of copper from cables. But What is slightly worrying is it says, where does it say it now? The charity is committed to collaborative working. There is a, where's the bit about the obligation for the networks? My eyes are going.
Don't know, but it says here,
yeah, I've lost
opportunity to help mitigate the risk has also been recognised and considered by the committee responsible for developing the 18th edition. So this is pre-18th edition. Okay, where they talk about foundation earth, electric areas and all this stuff. My concern is the electrical safety first committee roundtable, which has people from all sorts of other little organisations, including CPSs and the like. Why couldn't they have this discussion, see the risk, see the likelihood, and at least say, well, let's at least tell Sparks to check with the clamp meter? Why couldn't they at least do the minimum when they discuss this to this level? I mean, for that work to have taken place back then, why couldn't they at least said, well, look, let's push some supportive guidance to help prevent the risk of electric shock?
All right, this is what worries me, Dave, is the charity is committed to promoting collaborative. This is not a dig at electric safety first. They've done some amazing stuff for the industry, by the way. The charity is committed to promoting collaborative working. And while electrical distributors are legally required to ensure safety of the distribution network, we believe the electrical installation sector can help reduce the risk that open pen conductors present. So nothing's happened from then. So I can tell you now that I'm chair of another electrical safety roundtable, and we are going to produce some guidance on this. And that guidance, I can tell you now, will say use a clamp meter, because that's the first step of precaution we need to take, because this is a huge issue and there's no one solution fits all. As Gordon has rightly said, network configurations, local conditions must be considered. We just need to raise the awareness of it.
It's got to start with awareness. It's got to start with awareness.
The interesting bit, Dave, is the legally required to ensure the safety of the electrical distribution network. Now, I can tell you in the Western region, when electricians ring 105 and they say, I've got a lost earth, the NEO say, just stick a rod in, it's not my problem. When they had that installation had been supplied by an earth for decades. So I do think there is some poor behaviours in the industry now about, maybe it's due to volumes and how they repair it. But I do feel like sometimes a lot of it's getting thrown onto the consumer rather than the legal obligation of the network. And that's not a dig at any one DNO. It's an observation from us speaking to hundreds and hundreds of electricians. And this is one of the things that maybe even the IET need to be wary of. And ourselves, when we're doing this, is guys will listen to this and look at the advice of the IET, and they may get kicked back from the DNO. And it's not about kicking the DNO. This is a genuine safety concern. And yeah, do you know what? Sometimes we may need to take suitable precautions to reduce.
If we do something as simple as add another module or another little bit of learning to like a 2391 course, to produce some level of understanding, knowledge, approach, some level of system of work and testing, then we can equip electricians with skills to identify this phenomena. So when they're out there, they're obviously working more safely for themselves, but they're also going to help the DNOs by trying to raise awareness to this issue.
Yeah, I agree.
Yeah.
And that kind of really brings us to an end, really, of the research we've done and this little debate amongst a group of peers. What I'm going to do is I'm going to ask Gordon for your thoughts and feelings on Diverted Neutral, and we'll go around and ask everybody for a summary of what we think.
I think the guys used the word awareness there, and you know, from Discovery, the presentations I did, the training, the video, everything was all about keeping the guy safe and understanding this, like, you know, and the simplest device and the simplest test should keep the operative safe. The fix, how you fix the network, how you resolve this is a much more complicated matter, but this was fundamentally about keep it simple. Give the guy the information he needs to keep himself safe, make sure he's aware of it, he understands it, and he has the tools and the ability to protect himself.
Awesome. JW?
Yeah, I think the main issue thing is that if you're going to be disconnecting any kind of conductor, stick a clamp meter on it first and just make sure that it is actually completely de-energized, because it might not be.
Paul?
Yeah, I mean, awareness, obviously I'm not going to go against the flow here, but what I would say is maybe the Sparks need to think about their clamp meter as a bit of PPE even, because, you know, one of the things we do when we identify a safety issue, one of the quickest fixes is apply PPE, get the guys in PPE. You know, everything's a traditional PPE, hard hat, glasses, gloves, boots. But, safe isolation, it's your personal equipment. It protects you, but once we've identified the problem, we've got a sticking plaster fix on it. In other words, we've highlighted the issue. We've made the guys and girls aware of how they can identify this potential issue, so at least they're working safely. And then the long-term fix is to eliminate the,
Yep, I don't disagree with that. Mr. Watts, sir?
Awareness is clearly the best tool that we have, raising awareness, using suitable tools, bear in mind, we talked about the point here that the earthy conductor, which you may assume is always idle, is there to protect in faults when faults occur, may already have faults, and you won't measure a voltage on that. Clam meter is the way. And you'll only measure a voltage when it's too late and you started to create a gap, and then there's this blue flash and this other noise coming with it. I'm going to be adjusting my training to suit what I already kind of have with regards to having a working policy. And I think all electricians need to think about how they can equip themselves with the right tools and just always check for it. It's a simple little thing to do. And the IET, I believe, are updating their awareness media on this at some point. So do keep an eye on the E5 Instagram, because as soon as that's out, we'll share that out as well.
Yep.
Not long to wait now, is it? It's the third, 25 days, and we've got
Amendment 2.
Amendment 2.
Amendment 2, yeah.
And hopefully the guidance notes won't be far behind that. Certainly, I would hope that guidance note 3 is going to be very, very close on the heels of Amendment 2, if nothing else.
Well, I've already ordered my books and my GN3, so I'm looking forward to them coming out. But from my perspective, before I end this, Gordon, you're a legend. Thank you very much for coming in, supporting this, and offering your views and opinions. They are incredibly valued, and thank you for your service to this industry as well. And I love the fact that even when he retires, you can't keep a good engineer down. So thank you very much for coming on, Gordon. It really genuinely is appreciated. My final thoughts on this is, yes, awareness. We haven't got all the answers here. The IET won't have all the answers, but you guys need to adopt a common sense approach. We've identified in a few podcasts some very serious causes for concern. And the number one thing is for you to stay healthy, happy, earn your money, go home to your family, and protect the people that you work for. There may need to be some changes in attitudes and behaviors and working matters. But hopefully from these, we've shared with you evidence that these things do happen and can occur. We don't want them to happen to you. We're not saying we're the source of all knowledge and everything we're saying is right. But what we are saying is take the measures to look after yourself. That's the most important thing. We're not digging any DNO or anyone else. This is just research. We're just trying to pick this pattern up and make people aware. That's all we're trying to do.
Yeah, and there are other people in the industry saying the same. Obviously, the IET have done this open pen article. Yep. We're not the only ones around the industry that are saying that, there is an issue with neutral current diversion.
Yeah, absolutely. And hopefully, and guys, please, the E5 Instagram account, there's lots of images. There's more images, actually, because I realized I've got a video of a hole steaming from a broken neutral that I could have put in here. So there's more images, more videos of diverted neutrals for your consideration and viewing if you don't believe what you've seen today. Hopefully, if you have watched on YouTube, you can go away and look up the documents for yourself and read them, create your own awareness, create your own content. More importantly, feed that back to the IET. They're the central sources of information. The committee guys will be really pleased to have that information. And other than that, I can only thank my tag team partners and my brothers. Wish you all safe working, happy, whatever you're doing. So thank you for watching. Thank you for listening. And until the next one, which there will be, and I'm just going to say one last thing before I say goodbye. There may be a solution to all this, but you'll have to wait for another webinar to cover a podcast to cover that one, which we will. So until the next one, take care of yourself and each other. Goodbye.
Bye.
Bye.
Goodbye.
That's it.